Hi, welcome to the lab. So, the last video we worked on a simulation mode for our deterministic finite automatons, which we created in order to build a parser scanner, not parser scanner, a scanner generator library. So, and today we will continue working on our scanner generator. And in the first step, and today, of course, so basically the automaton is basically finished. Now we just have to run it. And for that, I would like to build a small example, like just right in our main class here. So how does STD getLine work? So basically, I would like to create a small REPL getLine. Isn't it called getLine? Yeah, it is called getLine. Okay, sure. It is in string. So let's include string. And how does it work? I give it a string, for example, and the default allocator is fine. And yeah, sure, let's just steal some code. I just want to do some basic code. Just would like to have some basic code. And you can provide a string, a input string. Well, but I want to give it std. Can I give it std in? And I can also give it a separator. This is fine. So, but how do I give it std in? Can I just? So an input string. I think std in would be fine. cin. So sorry, I don't know the C standard library. And I just give it a input strings. Okay, sure. But can't I give it just a string? This input string. It is not defined. So, does it work now? I think it might work. It accepts an input stream and a string. Okay, I think it should work like this. So, so basically, this should be okay. So let's just debug log. Done in the end, and let's print a little prompt. And let's just print the line. So let's prefix our line variable with C. So C line, std's line, std line. And I would like to use my own data types. And how do I give it a? So the data and the size. Yeah, so like this. Now I should be able to print it really easily. So let's just run it and see what happens. Does it work like this? So sure. Seems good. Good enough. Well, this is of course only for testing. How can I control dirt? We literally have to check if input is this horribleness. So let's if line empty, let's just continue. Also, if line is equal to control D or line is equal to control Z, then just break. Else we just repeat what we are doing. So just to get going. So basically, I would like to build the simplest possible REPL where I can just type something in and I can control D it. Perfect. So that's it. Basically, I don't want to do more. And now, instead of just printing our line, I would like to use the scanner, which we constructed earlier, to just run it on the line. This is what I'm going to do now. So now, so basically I would like to construct a new scanner every time, or maybe let's do something like this. I would like to give it a let's call it let's sketch out an API. So I would like to build an abstract class which is able to work with different kinds of scanner specifications, so to say. So I would like to have one class which I'm just giving the grammar, and it uses simulation and is, well, it will be a slow implementation since it will have to search in my data structures. But of course, later on, I will also introduce another implementation of this class, which is going to work on a table, which we will generate in one of the next videos, I think. So in this case, I will just create a DFA scanner driver instance. Let's call it scanner. And then instead of logging our line, I'm just going to say initialize line. And then so now we have our scanner is initialized, and then I would like to have a way to iterate through all tokens. So maybe like this, while scanner has next token, scanner next token. And then I would like to be able to just print our tokens. But for now, so of course this won't compile since this class is not defined yet. So let's do the following. Let's create a class called scanner driver, which will be the abstract class. And then immediately create an implementation for it, which I'm going to call DFA scanner driver. So, and then the scanner driver. So let's just add them all to our CMake. Scanner driver. Scanner driver. So now, basically, it already should compile. Yeah, cool, perfect. So this class will be virtual. So I'm creating a empty public constructor. I think so. Let's default this. And the destructor will be virtual, of course. And well, I think it should be okay to just default it as well. And now to the API. The public API, I would only like, so let's just include this for now. So if a scanner driver. So of course, let's also move it into our sigil namespace. In this class also. And let's already inherit from sigil scanner driver. And this should be a final implementation. So, and of course, we already sketched out what? Yeah. So I moved it into the namespace, of course. So let's introduce the public API mentioned here. So this should, of course, be implemented on our scanner driver, since it should not change. So let's give it a string view. Input. But let's also put a file name, file path. So for error reporting. Yeah, I think so. Or shouldn't we give this? I don't know. I'm not sure. Let's just ignore this for now. So, and of course I have to include string view. So what we need as well, we need a method called hasNext and next. So, and those should not be virtual. So bool hasNext and a method which gives us a token back. So how do we want to describe a token? So what belongs to a token? A file position, a lexeme, and the token type. So this API for now. So this is the API I would like to have. So, okay, sure. This should be fine. I think I'm just overthinking it already. So a token is just a token index, and I think I'm just using unsigned 64-bit integers. Token ID, so kind type. How should I call it? Let's initialize it with a negative value, since the tokens we construct all have non-negative ID, since they are basically indices into a table. So the -1 is an invalid token by default. And of course, we can't give a more precise type here, since the token type depends on the user's token. So I think I'm just 64-bit integer should be fine. So we have a token, and it contains a lexeme, and a position into the file, or a range into the file. How do we want to model this? So I think I would like to do a file position. I don't really would like. I don't want to work with just offsets into a byte stream. I would love also get the line and the character, so the line number and the character in the line. So let's do this. So let's just model it for now. Let's do a file range. So we point to a file path and a range so a file position is a So a line and a column. So, and a file range is just a range between two file positions. So I think this is how I would like to structure my file ranges, and then of course the token has a range. So this is what I would love to have. Maybe we will take a shortcut first, and so then of course my scanner driver also needs the file path, since we need the information somewhere. So this should be fine. So this should be the API. So how big is the token now? Like 8 bytes, 24 bytes, and yeah, like 8, 24, yeah, 32 bytes, I think. So this should be the public interface of a scanner driver. And I think now the program will build, well, it won't link. And I'm just going as a file path, since I'm passing in a string, I'm just going to something like this, so REPL string or something, so that I get dummy file positions when using in this interactive way. So now it won't link. This is what I expected since we did not implement anything. So let's do this. So I need the initialize method and the has next and the next. Hey, IDE. So, and let's just hide this. So of course we need to remember those strings. So let's do this. And here I'm also going to reset the scanner state. So how do I would like to do this? So I think we also need some more functions that subclasses of this class have to implement. So basically the interface to the underlying automaton in which, however it is provided to us. So let's just introduce a virtual method which is going to return the start state. And it shall be const, please. And this one is pure virtual, I think. Yeah, it is not implemented, sure. Why is next? Oh, I didn't implement next. Whoops. Let's just return a dummy token for now. Everything should be default. Well, I think. So now it should be implemented. So token is default constructible, isn't it? So a range and a lexeme. those can be default constructed. Yeah, should be fine. So of course this class now implement. What do we need to implement? We need to implement start state. Okay. And we also provide a constructor where we just have to pass in the whole grammar, I think, or the DFA. But the DFA is not enough. Yeah, it should be. Well, it should be enough. Let's look at the DFA. Do we have every information we require? Our DFA has the transitions, the states, and we know the accepting. We know whether it is an error state, an accepting state. We know the token index. So this should be everything we need, I think. Well, our start. Oh, we just return an integer here. So let's change this to a more precise type. A 32-bit integer should be fine. We should not have so many states. Yeah. And I think we can just pass in the DFA. So this is called automaton, like this. So, and now we should be able to return the start state. And I don't need to prefix everything with sigils and are in the namespace, corresponding namespace. So the start state. Start state. But it can be null. And we have a ID. This is a how do I want to represent states? I think in the scanner driver, I would like to represent states as integers, as 32-bit integers, but this operation might be able, so start state should never fail. So let's just use unsigned 32-bit integers for states, but operations that can fail, such as, so there are some operations that might fail, and then I would like to extend the range to a signed 64-bit integer. So let's just mark this explicit. Fine. So the ID is unsigned 64-bit integer. Yeah, but I think we're just going to cast it. So now our scanner needs our grammar. No, the DFA, of course. So everything should build now. But of course, whoops. Didn't I implement this? No, I did not. Thank you, compiler. Okay, cool. So now I should be able to run this. Of course, it won't do anything since our hasNext method always returns false. So how does it work? So I think I want to do as follows. So as far as I understand this, we store in our hasNext method we do the following. If we have a token if we have a next token, then we're just going to return true. And if we don't have a next token, we're going to try to get a next token. But this is stupid. So let's sidetrack for a bit. Well, maybe not. hasNext token false, and else I'm going to store the next token, full constructed next token. So then, hasNext, I'm using the wrong naming convention. Just noticed. So I always use the camel case naming conventions, but now I'm trying this one out here. So that's why I'm mixing them up. So if we have a next token, we have a next token. But if we don't have a next token, we call method. And then we get next token. And then we return our flag. I think this is what we should do. So, and of course, we introduced some state. I think I can just mark those as const just for me. No. What happened? What did I do? Now, so I'm just going to mark. No, I can't mark it as const. Never mind. So we introduced some state And those variables are called m underscore, and I'm going to reset everything back to their defaults. So now I have to implement get next token. So, and this will basically do the heavy lifting. So, in next, I think in next, we're just going to assert that we have next, and then we can just return the next token. We are moving it. And then I think we can just return it. And of course, we have to reset the flag. So let's include utility for std move. Well, let's just do a copy, and then we're just going to reset it as well. So token. So, and now get next token basically will use the automaton. So we're just going to U60 S64 state, and we just call start state. We're just getting the start state, and then we're consuming characters as long as we have characters. So then let's do the following. So basically now I would like to iterate input. So let's so basically I would like to introduce another method for this. Which is just going to keep track of the offset into the file. So let's just remember our offset, character offset. And also line offset and column offset. So now I can peek a single character. So let's do as follows. First of all, we're reading a character out of our input. So what do we like to do? If our input dot size, if the offset is greater or equal to the offset, we're just going to return -1. So -1 we use this as an end of file marker. else can read the character offset and move the offset position. Okay. Ah ja, unsigned char, fine. So now we have the next character, and so we have to return this, of course. But if the character we are looking at is a line break, we are going to offset our line offset. And in this case, we also have to reset our column offset. So now we can get a character, and using this character, so how do we have to pass this? So as long as we are looking at a valid state, so just we're eating we're always returning the prefix, the longest prefix match of the input, which matches a valid token. I think that's what we're looking for here. So we always start in the start state, then we try to run our automaton. And the automaton decides how scanning in this case is going. So I think so. So I think let's just play with it. I don't know. So we need a break condition, of course, a termination condition, but for now it should be fine. So we're just going to read a character, and then we are next state. So we do a transition. So, and of course we can't do this forever, but next state, of course, needs to be another abstract method. So next state. So in this case, we could potentially reach an error state. So that's why I'm using sign64 as a variable, as a type for a state. So when we get a valid state, now we get any state, and the next character. We get a character. Yeah. So, and then we return the next state. Something like this. But of course, now we have to terminate somehow, somewhere. So I think it works like this. while we are not accepting, we are just going to iterate So how can I answer the question if this state is accepting? How do I implement such predicate? I could do the following token. So let's do it like this, I think. So basically, this method does two things at once. Accepting token. Let's call it like this. Oh, and now I can implement predicate is accepting like this. Give it a state ID, and if the accepting token of this state is valid. So let's ignore this. Also, let's also define it as an abstract method. So we don't need this yet, but we will need it later. So while we were not accepting, we're just going to iterate and skip everything, and then while we are accepting, and we accept the same token. So in this case, we accept a state. So let's call this last accepting state. So now let's ask. So this was the last token we accepted. Now I can do as follows. So while this state is accepting and we accept the same, I think this is not correct. We always have to accept, but it depends. Well. So something like this, basically. And we have to remember when we start accepting and when we end accepting. So, but this is not correct, I think. So let's cheat. or something like this, I think. Let's re-engineer this. So I think this is not correct. We always begin with start, but I think you have to keep track of a lot of things. We have to keep track of all of this, but we have to call. Let's introduce a helper enum. A class, no, a struct, which I'm calling to, which I'm going to call state, which just includes everything like this. I won't prefixes it by m. So and this is just going to call offset then. So now, so this is a scanner. I'm just I don't want to call it state since I'm calling those states as well. So this one is the scanner state, not the well. This is also not really valid. So this one are the file offsets. And then I also have to keep track of other information. A state. I think I have to also remember the date. So and then of course I will be able to keep track of multiple of those. So I have and for now, of course, I'm just keeping track of the current state. Current line, current column. So, and of course, else I have to advance the column. Well, like this. Oh, well. So I'm advancing the offset into the file. I'm advancing the line and the column. Sure. I think so we can break. So when do we stop? Let's call this function only if we actually can call it. So let's assert. I think I have a better termination condition here. So while we can I think this is the way to do this. So my idea is to do as follows. So we just try to pass as long as we get an error and keep track of the last accepting state. I think this is the way to go. So we always start at the start state, but the last state was invalid. So for example, let's say our scanner should only be able to pass open parentheses and closing parentheses for now. Well, beautiful symbols. Beautifully drawn. So let's use another color. So then, if our scanner is able to pass those two characters, then the underlying automaton looks something like this. We have a state calling 0, which is the start state, and then we can either see open parentheses and come here and reach state 1, and state 1 is associated with the token C. So this is a character, the token. So it is not a C, it is of course an open parentheses. And then also we have another state which is called, let's say 2. It is also accepting, and it is marked with closing parentheses, the token name closing parentheses. And then there's a explicit error state, and basically on this transition get everything which is not an open parentheses. Well, so let's just say not. So anything else we reach then we reach state 3, and it is not accepting error state. It has an edge to itself, eating every other character. So now let's say we have the input string open parentheses, closing parentheses. It's a valid input string as far as the scanner is concerned. So we start at the beginning during parsing. So we have an pointer the beginning of the input string. We didn't consume any character yet, and we started in state 0. So let's keep track of this. I'm going to redraw the input string like this with a little bit more space. So now we are here, and also we are in state 0. So then we consume the first character, then we were here, and we are in state 1, which is everything is fine. So this is not an error state, but it is not accepting. So, but then we are in 1, and 1 is accepting, and then we see another open parentheses. So I think I forgot to draw some edges. So I think we should reach error states every case. So like this. So then we are in state 1 and see another open parentheses. We reach 3. So, but this is fine as far as and of course, if we see another character, we stay in the error state. So, and the scanner, I think we should do the following thing. We should remember where we start and try to pass as long as possible, as long as we don't reach any error state. So in this case, we should return this token as our match. And then if we call next token next time, we should reset the underlying automaton and just begin from here. So that's what I'm thinking of doing. So let's try to do this. So let's So then this means that we have to reset this state, but we don't have to reset this. Maybe let's put this into another class. So maybe let's for now do something like this. Let's call this position. And then, so the position doesn't reset, but the state does reset. State resets. So I think it can be local. But the position, of course, doesn't reset. Okay. So then, of course, we and of course, it also needs a, well, I'm not sure. Let's try it. So in this case, the start state, we start this. And I think what we saw here, since we have to continue parsing until we reach an error, we need something like is error state, and we pass in this state. So while we are not in an error state, and we can see something, we can peek, we do so. So this means is error state. We have to introduce another virtual method, error state, or another predicate which we have to implement later. So, and I think this should be fine, like this. And then, of course, we have to see if we reached an error state or not. But we, of course, have to track a lot of meta information, such as the positions. So I think we're doing something like this. So I think we have to do something like this. If our current state is accepting, if the state we are in, and of course here it is the start state, then we have to remember positions. So we have to complete state. So let's include the accepting state. Well, and of course it might not be accepting at this position, so -1 should be fine. So this position has this accepting state. I think this should be fine. So, and then we remember the last accepting state. So now, if we are accepting, we just remember that we are accepting. So state. So I think we can always do this. So, and if this state is accepting, we're just remembering it. So last accepting is good. And this, I think, we have to so this will basically keep track of the positions in the file, starting from here And let's say we pass an identifier. Let's say we have a different automaton. I think we also have to keep track of more things. So first accepting or something we need. I think we also need something we have to also keep track of this beginning. So like this. So basically, so I think I'm not communicating my thought process very well, but I'm currently also trying to think of how this could work. So we start at this state. We remember I think. So let's do the following. I think we have to do something else. So so I don't have to set this every time. I'm not allowed to set this every time, am I? Yeah, I should. So I think I have to do this. But only if this is accepting. So I reset this value to -1, but if we are accepting, I set it to state. Then I'm remembering the first and the last accepting state. Something. And then, of course, I have to update last accepting every time we reach a new state. Copy paste this, and only have to update last accepting, since first accepting points to the position at the beginning where we start accepting. So first accepting then will point, for example, to this. Last accept this once we reach this point. Now, next character, if we consume the next character, our current position reaches this position. We have to return this token, and afterwards pop this point, set this point to this. I think this is what we're going to have to do. So, of course, first accepting and last accepting start out at the same position. So both of them start out here. And then we consume the next token, but first accepting stays here. And last accepting is moved forward. Yeah, I think this is how it works. So then, when do we restore this? I think we restore this if we are. So basically, I think if our is error state, last accepting state, if the last accepting state was not an error state. This means we actually saw a token. Then we basically construct a token. Else we get an error. So an error last accepting. So this means that we reach an error state. But I think this is not correct. The accepting state. So I think I have to debug this. So I think in this case we have a scan error. Let's include for logging. Oh, called formatting. And then I can just debug log make token just to print something, and I think we reach this. I get a scan error here. So let's see. We don't have to return anything, and yeah, oh, sure, now the compile error goes away. So I think I'm just going to check those methods. Can't it just generate them? Well, let's just copy them all. So let's see what we can actually do here. So I think I can do the following thing. I can create an internal method, which I'm just going to call get state. State by ID. So, and here I'm just going to states inbounds. So because I know that the index is the ID is just an index. So I can just access the states and get the ID's index. And this returns a pointer, yeah. So this should be fine. And of course, I don't want to modify anything. So I'm just going to mark this return const state pointer. So then we use this method as follows. So those predicates basically do the same thing. I'm just going to get state by ID, passing in the state ID, and basically I'm just asserting that it actually exists. I don't really need to assert this. Well, let's just do this. So I would like to call this one state. So let's call this one, let's prefix this with L for local. I hate it, but it doesn't really matter. So, and then a state knows if it is accepting. So in this case, I'm just going to delegate to the underlying predicate method. So, and I think I can just copy this a few times. So, but in this case, I'm going to delegate to isArrow, and in this case, I think I'm just going to assert that I'm actually accepting. If I'm accepting, this method should have worked. So then I can just return state by ID token index. So this method gets the index, the index of the token that we actually accept. So the ID of the token, but I know this is an index into a table, so it's not perfectly named, but it doesn't really matter. So in this case, it works a little bit different since I think we have to search. So I think we have to search the list of arcs. In the DFA, we have to search in the list of arcs. We have to keep an eye for arcs that start from state, from source, and that do the transition with this character. So, and arc parse that contains the character. So, and this should be deterministic, so we should never reach this point. So false and unreachable. So we always should find a follow state, the next state. So of course I have to return something here, but what do we have to return? The ID of the target state. So I think those are all the methods. So let's see what happens. So I'm just going to run it. And let's just give it a token like plus, an easy and simple token to start. So now I should have debugged it a little bit more thoroughly. So let's do this. So initialization, it's just setting up some variables. So has next. We should not have any token stored. So we try to get the next token. And during this, we start in state 0. No state is accepting here. So we do reset this flag. The 0th state, I think it should not be accepting in our case. So, and then 0 is also not the error state. We know that since, well, it prints it. So 0 is not accepting, and 0 is not the error state. Otherwise, it would have an exclamation symbol after it. So, but this is not correct. I think I didn't swap this predicate. So let's try again. So now we should enter this loop. We get the first character, which is 43, I'm sorry. And it should be plus. So numbers are hard for me, since let's give some trivia. In German, we see the numbers, you give them in a weird order. So for example, if you say 143, in English, you will say the, trivia. If you say 143, you say the digits in the order they were written, but in German, you say the, how is it called? The last digit before second digit, and that's why I'm always mixing up the ordering of the numbers. So in German we say 143. So 100 is 100, and then you say 3, which is 3, and then 40, which is basically the 4. So it's a different ordering. So I'm always mixing up the last two digits. So that's why I call this 34, even though it's 43. So, but this is our plus, which we actually see. Then we do a transition. We reach state 6. State 6 is accepting. So we remember that we accept in the current state. And then our input should be done. Yeah. Okay. So then we return a token. Since our last accepting state was 6, and 6 is not an error state. I see. So this works basically. So, and then make a token. So what does our token look like? Our token has a type. So this is the type of the token, the lexeme, and the range. So what do I have to construct? So let's just fill out what we have to construct. So the token type. This should be easy. This is just accepting token of the last accepting state. So done. Then the lexeme. And then the file range. Which we have to define. So a file range is a file path and file positions. Okay. So the file path we have as a member, then 2 file positions. The positions are given by offsets. So, and we only care about the line and the column, not the offset. Sure. We have the offset. So we have the first accepting line, the first accepting column. And the last should be last accepting. So, and of course, it cries about being the invalid type. It cannot be narrowed from U64 to S64. I did it again. Oh, 64 is right. 64. Sorry. So those are. I'm acquiring unsigned values here, but the token. Let's use signed 64. I'm just going to cast it. Should be fine in all cases. Okay, sure. So now I have a token. The lexeme, of course, I don't have the lexeme. So the lexeme is a substring basically of my input. So input substring. So substring. Should I call it substring then? Or should I call it subview? So let's call it, give it some silly name. And basically, thanks, I think we have all information. So I'm just going to cut from this offset to this offset, the last offset. But should this one contain, so do I want to give it the first index and the last index, or the first index and a length? So I don't think I need this method. So lexeme just going to be an input data plus offset, and then the length is, let's just cut it. So this of course is first offset. So an offset is an unsigned 64-bit, but my constructor wants a signed. So let's actually cast this first. So I think this should be it. What did I forget? Hello? Oh. Of course it should not return a value. So then I'm just going to set next token and set the flag that we have a next token. So let's keep it like this. Let's rerun this. So let's skip everything, which we already debugged. We reach our first case. So we construct a file range. The file range points to my dummy string, REPL string. The first position is 0, 0, and the second position is 0, 1, since our first character is a plus on the first line. So this looks like it works. So let's see if we actually get a lexeme. So our lexeme points to plus with the size 1. So it looks okay. So, and the token, of course, now, why is the type 0? Is this correct? How is the state initialized? By -1. So the first is plus the first token. It is, so it looks okay. So then I'm storing the token. But I think I have to reset this. Reset it somewhere. I think I have to reset the state here. So current, in current I have to reset to last accepting. Yeah. And first of accepting, this is fine. I think it is fine. Should be okay. So let's try this out with longer input string. So let's say plus star, and then let's just do plus star if. So then we reach has next. We don't have a next token stored. We get the next token. So the first time we already debugged this, so I think this will work. In this case, the lexeme would point to the same string but with the size 1. So I think this worked. So now the token type, since now we have plus, so the input string was plus star, should still be 0, since plus our first token. Plus is the first token, yeah. So this looks great. So then we reset this. Print. Is this correct? Yeah, should be. And then we have a token stored. So has next returns true. Then we consume the token. Then we don't have a token stored. So we get the next token. So we skip one character, which now should be 42. So 42 is 42 the times operator. It is. So now we reach state 5. 5 should be an accepting state. So we remember that this was the accepting state. We can now pick one more character. So we do it. We do the transition. We now reach state 1, which is our error state, because we saw the times operator, and from the times operator, every other leads to the error state. So is expected behavior. So we don't remember those things. And now we get back to the head of the loop. 1 is our error state, so we should skip this. So, and of course, now we saw last accepting. So we did previously accept, so we should enter the first case. So let's see what we got here. So we have a token which type 1. Type 1 is the star, so the first token matches. We reset the internal state. Oh, sorry, I also wanted to check this. So this one is not correct now. I think I have to remember this here and then reset. So first accepting was not correctly set. So the lexeme should have pointed to the star, but it pointed to the wrong thing. So let's rerun. So I typed in plus star if. So the first time it worked. So I'm going here a little bit faster. I haven't changed anything. So then we go back to the next loop. We go back to here. So first fine, then we see the I think the I get the next state, which is 1. It's an error state, so we terminate. So let's see, what does our token give us? So now it points to the correct position. From 0, 1 to 0, 2. So this also is correct. So it points to the correct position. And then we remember that we set a token. Then the method will return our token, reset it, and be fine. So now we should see the if token. So we don't have any token stored. That's why we get the next token. We start from scratch. We are not in the draw state. We're consuming a character, seeing the if, transitioning into state 10. State 10. We don't currently know which token it corresponds to, but it doesn't really matter. 10 should be the identifier, I think, since I is a valid identifier. So we remember this as a accepting state. Then we should see the F. 102. Yeah, so this is the F. Now we should transition into another state, so state 13. We remember that we saw this. Then we terminate since we reached the end of the input. So we have a last accepting state set. So we are going to construct the result token. I'm just going to have a look on it. So we accept token type 6. Token type 6 is indeed the if token. Well, this works perfectly. Does it point to the correct position? It points to if with a size 2. This one looks fine. And our range, well, this is a dummy string. It starts at 202, which is the second character, first line, second character, and it ends basically. I think this works beautifully. So then we should have a token set, so we can print it. So, and at the end, no token is set. We try to get a next token, and basically it will immediately skip the loop since we are already at the end. But why do we reach this state? Last accepting. We have to reset those. Or do I have to accept these states? Let's do this. I don't have to do this here since I'm resetting the state. So sure. So we reset it, but we reset it again if we learned that our state is accepting. I think this should be fine. So let's run this code again, but let's remove this breakpoint. So then we should reach this loop 4 times. This call method should get called 4 times. One for the plus, one for the times, one for the if, once after that. So I'm just skipping first call, second call, third call. Let's look at it. Now we reset our state. Ah, yeah. Okay, sure. What happened now? Ah, -1, I think. We reached. Can I just initialize it? Not with -1, but with a valid state in my universe. So the valid state. Valid state. I think this a valid state in my universe. So let's initialize this field by our error state. So is there a way to get the error state? No. So let's introduce it. So we get the start state. So and then we should also introduce a way to get the error state. So let's search for it. If st is error state, then we set the state. Assert that the state null pointer, there should be only one explicit error state. So, and then we are just going to remember that we saw our error state. We continue, so we assert that we found an error state. We're just returning the state's ID. So this should be the implementation. So then we reach a scan error, which is not correct. We reached the end of the file. So, but I think This one is only a scan error if we actually are in the error state. So is error state current state? If the current state is the error state, then we are a scan error, else we just don't have a token. But I think this should be fine. So let's run this without debugging. So of course we don't print anything, but let's do this now. So now let's print the lexeme and the token type. I think we can just, do we have our DFA at hand? Yeah, we do. No, the token names, token ID. Token type, sure. So let's debug log the token name. Yeah, let's just only print the token names for now. And let's run our example. So now I'm a little bit excited. What happens? Yeah, well, let's remove the debug print for now. Okay, sure. Accepts the first token, the second token, and the third token. But then it thinks we have a scan error. Which is not the case. We reached the end of this string. Why does it think we get a scan error? Since the current state points to the invalid state, I think. Yeah, we set the error state here. But how do we get this to behave correctly? I think I'm missing one single bit. Not really sure. I'm missing. So we are at current state is an error state. Then we detect it as a scan error. But I think this is not correct. It is not correct. Just read end of the file. So we can, for example, recheck this. So I think when error occurred, we are in the error state and we are not done. Does this solve the problem? So let's do again plus times if. So now it seems to work. What happens if I what it puzzles it. Okay, let's also print the lexeme. So token lexeme. Works. I think there might be some problems, but I think this looks already great. So we see I typed in hello space world and it prints hello white space world. Whereas of course, white space, those names are the names of the tokens I gave it. So let's test a little bit more. Well, this doesn't work anymore. So I think I'm not resetting the state. So I'm reusing my scanner instance. I'm not resetting the internal state. So let's see what I have to reset out of this and out of this. So those I reset, but those I still have to. So those I already reset. Or I just derped. So let's try again. Plus star if. The first example still works. Now 1 plus 2 times 34. Ah yeah, this looks better. So open parentheses literal 1 plus literal 2, close parentheses star literal 42. So now, how do we want to deal with scan problems? Scan errors and things alike. So do I want to include an error token? So how does our token look like? Token, yeah, okay. Let's say -1 is again the error token. So then I think if we actually have a parse error, we're just going to remember that we have a parse error. So in here, we're just going to, basically we construct a token like this. Let's just copy paste it for now. So of course the token ID is -1. So we didn't see anything, so we have no valid lexeme. So I can just a null lexeme here. The file range should just be should be fine. But I'm just going to try it. So and then I'm just going to remember this as token. So next token. Let's maybe name this error token, just to give it a more clear name. So let's cause a scan error. What don't we support? We don't support exclamation point or hashtags, for example. Let's just try to pass hashtag YOLO. Oh, well, it doesn't return anything. So I'm a dum-dum because I don't changed the way hasNext works. So if we have a next token or we have a next hasNext error, then we are going to this. I'm just going to reset all of them. So let's try to scan #YOLO again. Okay, perfect, works. So index out of bounds exception, in bounds, where is this? So it's the index problem. So I'm thinking this is this one, since now the token type can be negative. So token.type -1, and the token name is error. Else, well, I can also inline this. So in this case, it's error. In this case, it's this expression. Then, of course, the lexeme should be empty, but not crash anymore. So #YOLO. Okay. Just skips over the error. I think I also have to remember that we previously returned an error. So I'm thinking of doing this. So I'm just going to use hasNext token here. And let's say the following. If we already saw a scan error, we always return false. And if we have a scan error, we remember that we had a scan error. But this won't return a scan error anymore. So, but we now the next token set. So I think now I can just change it a little bit around. So if we have a next token, we just return true. Else, if we have a scan error, we return false. So if we have one scheduled for returning, basically, we do this. And then here we will reset this flag. And the next call, this flag should be prioritized since, well, I moved the code around. So let's just try to scan #YOLO once again. It just returns the error token. So what's the position? So let's also print the range. So let's do this in a separate method. So, and I pass it a scanner driver file range. Now, method of course have to implement, and I don't have to print it on the heap, but I don't care. This is for testing only. So token dot range base token name. Let's just to print something. Doesn't really matter. So let's implement this method. Let's create a string builder. So let's start by printing the file path. Format into this builder range, then a colon space. So file path, then the line, colon, column. Let's then also print the resulting position, so end position. So first, last. Oh no, not this one. Those. So we get file path colon first, the line of the first position, the column of the first position, then minus, then the line and the column of the last position. So, and this method also uses the wrong naming convention. I'm not really super consistent, trying to be, so I'm just fixing it. So let's run our program again. So now, of course, I should get in position. Let's see if the error position works. No, let's just see if it works every case. So plus star if hashtag YOLO, and maybe a literal. So let's try again. So 3 plus 5 times if YOLO. So the literal 3, so it's a little bit hard to read, but the literal 3 is from position 0 to character 1. The lexi 3, then we have a white space, 1 character further. Literal 5, so this seems correct. Star seems correct. Well, white space, then keyword if. Sure. Then we have an error at position 11, and 11 is so those ranges, last one is exclusive. Is this actually correct? I think I would expect that the character, this is the 0th character, so that line and column is both 0 based, but it is 0 based. Okay, so the last, so this one is exclusive. Maybe let's document this. Since first and last the name suggests that those are inclusive. So let's rename this to end. And let's document that this is exclusive. Now it is correct. So white space is the 11th character exclusive, so only the 10th character. Does it actually make sense? So let's copy this line here, just to get a convenience way to count column. So 11. But this counter is 1 based, so basically here the parse error. At the character which causes the scan error. So I think the positions work as well. Okay. This is some great progress. I like it. So now I think we have a working scanner driver, which is just a generic implementation. Oh, well, and I don't need this code anymore. So, and of course, this one is not the fastest way to implement this, since this driver implementation, well, it uses for loops to search for the correct states. You could also pre-bake them in a specialized scanner driver, which has tables for every of those methods. So we don't need to search anything. But well, it was the quickest way to test our driver. So, and I think I'm happy. I think there might be 1 or 2 little problems. So let's think of what happens if we reach the end. I think let's consider a valid input. So we are already we are running. So let's say like 1 plus 3. Well, 1 plus 3. Then we return 5. I know I did not. But let's just type it in. Oh, well, it doesn't work anymore. Since initialize has to reset scan error as well. Forget this every time. So every other state that we have to reset. Oh, no, just the scan error is new. Anything else we should have reset already. So now we should be able to pass something incorrect, use initialize again, and then pass again. So let's do this. So let's keep hashtag YOLO as a good example. So this caused an error, but if we type something else in, so for example, what did I type in before? So if, let's just shorten it a bit. If then 5, else whatever. So of course, if I defined, where is it? If I defined if as a separate token kind, but then and else just are passed as identifiers here. It doesn't really matter. So I would love to have an explicit end of file token. So I think this will be great. But how do I code this? Maybe another negative type. So token.type. -1 is already the error token. token. Should I just say -2 is the end of file token? I could do this. Let's do it. Or should I introduce an enum and then cast with? No, let's ignore this. Let's keep it simple. -2 is the EOF token. So end of file. So now I think I have to hack. I think I have to hack the next and the hasNext method. So we skip this over. We just remember hasReal token. So just giving it the name hasReal token. So if we have a real token, then we return true, else we return whether we already returned the EOF token. So, and then this is just this or this. So I can just simplify this. So this is true if this or not. Like this, I think. So of course, I have to introduce another flag. No problem here. So, and I'm saying no, I did not return it yet. Okay. So, and I'm asserting hasNext, getting the next token. But I think let's do this. So if we have a real token, we have a real token, we don't have a real token, that must mean that we return the return EOF. But we also have to remember that we return this. So we flag this as true, but before I forget it again, I have to reset this state here. So EOF returned false. Okay, sure. So now I have to return a EOF token. Steal some code. Delete everything. And in this method, I have to return it. So I don't have to remember anything. I just return it directly. So of course, this EOF token. So the position should be fine. And the type, of course, is -2. Where I don't have a real lexeme, I think we could construct one which points at the end of our string, but I don't know if this is if we really need this. We point to end of input. Not really sure though. So I copy pasted this code. Good idea to introduce a method for this. So current, let's say, accepting range or something. So a file range, calling this accepting range. So where do I put this? Maybe at the end. Scanner driver. No. What? Oh. All the shortcuts I don't know about. So this was a shift selection. No, similar, not quite, but doesn't really matter. So, and in this code, in the function, I'm just doing this. Then I don't have to name it, it can just return it. And this method I'm going to call here. And I'm going to call it here. And I'm also going to call this here, since this is copy pasted several times. So then UF token. Was I finished? So I'm constructing the UF token. Maybe I should point to the end of the input, but I don't really care right now. So, and then I have to fix my main method. So token type -2. Then I return UF. Else I'm returning whatever I'm returning the other case. So let's see if this works. So the explicit AOF token, I like it, but it's not really required, since we could also get this information in this iterator-like this iterator-like interface also already provides this knowledge, but yeah, it returns the EOF token. It's just a dummy token returned at the end. So can I still? Does still everything work? Test, hello world, if else, test, hello world, else, literal, white space, UF. UF is always the last thing. So I think it just works as intended. So this should be a simple scanner driver. So let's just do, we fix the naming convention of string builder to string. Well, fix, it was not really an error. So rename string builder to string. to match our naming con. So, and then let's just commit everything else as another commit. Let's include the changes in main. Those two. Well, so implement a scanner driver. The scanner driver implemented as a abstract class, the same for scanner driver. It provides a generic interface and implementation for different DFA representations. Currently, we use subclass DFR scanner driver this DFA automaton to simulate subclass DFA scanner driver uses DFA automaton to implement the interface. This is not the most efficient implementation since DFA scanner driver has to search for the next applicable. This word looks in. Applicable. No, it's right. Correct. State. So maybe let's also note that a table-driven implementation would fix this problem, this potential overhead. So what does it actually do? So the DFA scanner driver implementation, does it need to search in the next state? Always search. So the predicates are basically free since they are only lookups. Index lookups by index, but the next state method has to search, which is of course not perfect. The arrow state method must also search, but this is only used once, so this is not really a big problem, but once per scan. So it might also be not the best idea to repeatedly search for the state. Of course, I could cache it, but I don't really care. So this is not the most efficient implementation. The DFA scanner driver has to search to find the next applicable state. The table-driven version would fix this overhead. Eliminate the need for searching. Need to search. For searching? Need for searching. So I think now getting really close to finished with this little library. We have some more things to explore. For example, we have to create a table, I think. But also I would like to generate a scanner out of our grammar. So I think we have all the things in place we do this. So our grammar, our class grammar, we have the automaton, which is, I think, should be enough to just generate source code. So for example, we could highly specialize our scanner driver for the language we are parsing. So, or for example, we could also generate a version of this, an implementation of this class, which directly implements those methods using a big switch statement. And the information we need comes, of course, from our grammar. So the whole information is encoded in the automaton, and maybe we need the token names as well, but I think the automaton shall be fine. Generate directly a scanner driver implementation. So I think maybe we will explore something in this direction, or we could also write a tool which uses this library to actually, basically a scanner generator tool which can be used, for example, like Flex or Bison. But I'm really happy. We got pretty far and it works. It works great, I think. Of course, those tokens are not really finished. So of course, I would, for example, I would like that, for example, if I would write a compiler using this library, this program we are currently writing, then I would love that the tokens actually contain a processed variant of our input. So in this case, I'm also only keeping the lexeme around. But of course, if we have, we have a integer literal token, then I would like that this token already contains the parsed and processed value. But I think this would not provide, this would not allow you to create error reporting in the scanner generator. So I think maybe let's just ignore this. So I'm really happy. It worked great. There are some things to explore. But I think let's keep the ideas. So I already mentioned some ideas which we could do in the future. So where is it? The file is called draft. So we did this everything. We did this. So you could minimize the automaton. So currently, but this is only really interesting for a table-based DFA scanner driver. And in this, so if we do a table-based scanner driver, we basically create a big transition table where we have basically, well, this is a beautiful line, a big table where we just, let's do it for a few cases. So we here have every state. We list every state here, for example, 1, 2, and 3. And then all characters. So for example, a open parentheses and 4. This is the best language ever. So, and then, for example, we could always create a big table. And for example, if you are in state 1, let's say this is our start state, and you see an A, you stay in state 1. But for example, if you were in state and see a 1, you transition in 2, you transition to back to 1. And let's say if you are in 1 and see an open parenthesis, you transition to 2. So we could create a table out of the data we already have, and we could encode this table directly as an implementation of our scanner driver, for example, and we can then use this table to drive the scanner driver, basically. And for this table, it grows quadratic on this axis. Basically, we have all possible characters, which is, I think we handle them as U8, so 255. This stays fixed, this dimension, but this dimension grows with the number of states we have in our automaton. So the minimization could reduce the count of states, but yeah, I'm not really sure how to do this. Maybe I have to look back into it. So all of this stuff I had during my during college, basically. But it's a long time ago, so that's why I'm struggling, for example, with building the scanner driver. I could not remember how it's done, so I had to cheat 5 minutes. So I just scrolled through an old implementation, which I have done for, I think, before like 5 years. Then I remember how to do this. And also this image helped me a lot, so I could not read this from the code that quickly, but I remembered the idea, and then we were able to re-engineer this. So, and yeah, so for table-based implementation, minimization is interesting. We could also generate a scanner driver for a target language. For example, we could generate a driver implementation for C++. But also it would be possible to generate them for different languages. But of course, you have to re-implement this abstract driver, so the abstract class. And I'm not thinking that I'm going to do this. So I think I will generate a scanner driver implementation, but it's not really important. So maybe let's come back to why I actually wanted to write a scanner driver library. Basically, I would like to experiment with writing different languages and all tools, which all require some kind of parsing. And during development, I like to be able to extend the scanner really quickly. So in this library, well, it just allows this. So I can just write the tokens down, which I'm requiring, and then I can just call a little function, handle a little bit of error, and then I always get get a driver which I just can use for parsing. So I think this is really nice for quick language prototyping, just to get a feel of how the language, well, how it feels, and just to throw in a couple of new tokens and just have a look how quickly I can extend it. So for example, I would like to be able to pass identifier starting with an hashtag. So let's just add it. Done. So of course my labels are not correct anymore, but now I should be able to pass YOLO. I suppose. YOLO, hello world, hello 3. So now I get a hashtag token back, which just contains hashtag YOLO. So it was really easy, just add a single line here. And since the creation is really fast, this won't be a problem to play with the language or play with language development. So yeah, I like it. So let's remove the YOLO token, the hashtag token. So then let's wrap up. So thank you all for watching. I hope it was entertaining in some way or another. I hope you like to see me struggle writing the scanner driver. And yeah, have a great time. I hope to see you soon. Bye, guys.